Okay, ladies and gentlemen, looking at today's lesson, all we're doing today is finding the distance and the midpoint between 2 points. Distance and midpoint. So again, looking at today's objective is pretty simple. Find the distance between 2 points, find the midpoint. We're going to learn if you have an endpoint and a midpoint, how you find that second endpoint. If you can count, you can definitely do the third objective. But it's a pretty big if you can count. And then the last one is to derive the distance formula, which we'll go over that, but it's not anything that's hugely important for the course. So let's just get right into it. What does it mean to be the distance? What is distance? Awesome.
Distance is from, say, your table to the wall.
Okay. So what does that mean?
You're pretty much trying to find out how far one point is to another.
Okay, trying to figure out how far they are apart, right? All right, so let's take a look at this little grid that we have up here. And if I ask you then to find me the distance from here to here, is that pretty easily done if you have the grid?
Yeah.
Why? All right, then how do I find that distance if I have the grid?
Well, if you have the grid, just count by squares, and whenever each square goes up,
Yeah, all you gotta do is count the squares and we're done, right? And the same thing as if I was going north. Again, all I would have to do is to count the squares. But there's a slight problem when all of a sudden I'm not going left or up or down, but instead I'm going at a diagonal. I can no longer just simply count the squares. So there has to be a way, Joey, for us to actually figure out what the distance is between those 2 points without having to do a whole lot of work. What formula?
Oh, wait, I think I remember
A2
this.
plus B2 equals.
Yeah, A squared plus B squared.
A squared plus, oh, hey, Pythagorean theorem coming back to
That's what I
us.
meant, yeah.
A squared plus B squared equals C squared. Okay, what does A and B refer to? Oh, the base and the side. Okay, so guys, again, the A and the B are the 2 legs of the right triangle. It doesn't matter which one's which, they're the 2 legs. So in this case, we can consider this as A, and this side B, which means my distance is actually C. We have A, B, and C. Pretty simple, pretty straightforward, right? Okay. So yeah, if I count the squares this way and count the squares that way, we're good to go. I can do the Pythagorean theorem, and we're done. Right? No?
Because it's squared right now, you have to take the root.
Okay, let's try something else here. There's another direction I want to go with this. Suppose I didn't have the grid. Suppose all I had was 2 points. What's another way for me to find this horizontal distance? Caleb?
Add up the angles of the 2 points that you know and subtract 180 by what you added up.
Well, that would give me the angles. But, and Caleb, you're somewhere right there where we have the 3 angles of the triangle. We know all 3 of those add up to 180. But we're not worried about the angles between my sides. I'm worried about the length of the hypotenuse. In that sense, there's no limitations with the length. So how would I find, again, let's go back to this. How would you find this horizontal distance? If I didn't have the grid to count the squares, how would I find the horizontal distance?
I think you use like the equation by subtracting like one side. I don't remember how to do it, but I maybe use the equation to subtract one side or something like that.
Yeah. Well, here's why. Why do we subtract? Well, let's do it this way. Say I'm starting at 7. All right, my starting point is 7. I'm going to take a little walk. 8 steps. So you would say then that I traveled 8 steps, right? So I started at 7, I'm in at 15, and you said that the distance I traveled was 8 steps. Well, how do we get that magic number of 8? We subtracted 15 from 7. So I took my end value, my final value, and I subtracted my initial value, right? How many guys took ICP? You guys probably know quite a bit, right? Did a lot of VF minus VI, or you did SF minus SI. Again, it's just taking your final distance and then subtracting out your initial. So we look at this graph, this value right here. I'll use my little tablet to do that. So this value right here is x1. This value is x2. So what is my distance between them?
X1 minus X2.
All the way around. Take the final minus the initial. So x2 minus x1. If we go a different direction now, let's go vertical. How do I find that vertical length?
Y2 minus
y2 minus y1. And now, guys, we're getting close to Pythagorean theorem, or not Pythagorean theorem, but now we're getting the distance formula. Because now if we look at this, this is the horizontal. So that's like saying A. So now that gives me x2 minus x1 squared. Plus the vertical change, which is y2 minus y1 squared. And that all equals c squared. Again, c being the hypotenuse. Now, do I want c squared or I just want c? I just want c. So how do I get rid of the square? Take the square root of it. Okay, the only way to cancel out a square is to take the square root. And that's how we get the distance formula. So if I were you, I would box that in your notes and highlight that. That is the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That needs to be big, bolded, highlighted, colored pencil, box around it. Lots and lots of attention being drawn to that single formula. You're going to write that out a lot of times today. Yes, Casey? So again, here it is. That is your distance formula.
That's a Y?
What do you think it was? What do you need to work on your handwriting?
Okay.
One day, why you think you're
Let's go from here. Let's do a couple of examples. All right, I'm going to do number 1 with you guys, and we'll go from there.
It's gonna be 12 minus 2.
All right, here we go. So number 1, we have 2 comma 7 and 12 comma 7. All right, I know you guys are going to hate this, but every single time on your homework, in practice in class, your job is to write out the formula every single time. That's your first step of showing your work. So write it down in your notes right now. We're going to write down the formula. D equals square root of x2 minus x1 squared plus y2 minus y1 squared. Yes, Dylan, those are y's.
So they look like G's. Would the 2 and the 12 be the 2 X's?
Yeah, that's your x's. Yep. All right, so that's our formula. What's my x2 value? my x1 value? 2. Okay, so I got 7 for my y2 and 7 for my y1. Okay, what is 12 minus 2? 10 squared plus what's 0 squared? 10 squared is? Therefore,